In today's video, we'll learn about the design expert software and quality by design approach. We'll practically see how we render the independent and dependent variables in design expert software. So in the software, first of all, you will find this. Our design is multi-level categorical. So we have chosen multi-level categorical. After this, we will set the categorical factor. Okay, our categorical factors include percent of methanol and flow rate, so we'll put this, then we'll put the unit here, then our type would be nominal. You can also set this as ordinal. However, we have kept this nominal based on your responses and your analysis. Then we have used three levels. Okay, low, medium and high. Okay, these three levels will belong to your literature review and your type of analysis. So in our level we have set 10 as low, the percent of methanol as 15 as medium and 20 as high, whereas we have kept flow rate as 0.8, 0.9 and 0.1. So these are low, medium and high. So after doing all of this, we'll press upon the next, and this is showing the multi-level categorical design. Then you can just read out this, and we have set the units. The unit of retention time is minute, whereas the tailing factor and theoretical plate has no unit. We have also put another response, which is the resolution. Okay, so you can increase or decrease this by clicking here. However, in our study we have seven responses, so we'll press upon the next. So this is the design power. uh, After that we'll finish. Okay, so the design expert has given us these results. Okay, they have chosen different independent variables, and we can see the dependent variables here. Okay, so what should we do now? We should run the HPLC using this percent of methanol. Okay, and at this flow rate, and the result which will be found will be recorded here. Okay, we'll found the result here, we'll put the result here, and same, we'll run all of the 9 runs, and after that, whatever the retention time of the remeltion, whatever the retention time of vonoprazan, we'll put the value here. Then tailing factor of remeltion, then tailing factor of vonoprazan, we'll put them here. Then response 5 is theoretical plate, response 6 is theoretical plate of vonoprazan, we'll put all of this value here. And finally the response 7, which means the resolution of the two peaks. Okay, now let's do the analysis. However, completed the we have already completed the analysis, and now we'll put the values here. Okay, just I have already put the values. I will just show you our design in which we have put the values. So open design, and Remington corrected, just open. Okay, now these are our run that we have already discussed, and these are the responses that we have got from the SPLC method. Okay, so in this SPLC method we have found out different retention time of remeltion, then tailing factor of remelton and vonoprazan, then theoretical plate of remelton and vonoprazan. Okay, and finally the resolution. So these all values we have got from the machine of Shimazu SPLC machine. Now we'll perform the analysis one by one. Okay, so to undergo the perform analysis, first of all we'll click upon this dependent variable. We'll click on start analysis. Whenever we'll start the analysis, we now need to click on the variables. Okay, we have clicked A and B variables. You have to confirm this on the very beginning. Then after that you'll click upon ANOVA. In the ANOVA, this test has already been performed. You can see the F value, you can see the P value. Okay, we know the more F value, the more would be your you'd have the better result. Then this is the p value. The less the p value, the higher would be the significance. So our p value is very very less than 0.05. You can also see the mean square. So these are the some statistical tests that you need to learn from the very beginning. So this is the degree of freedom. We know in the statistics, in the ANOVA result, we perform f test, and for the f test you need to perform different uh, total sum of squared, then uh, treatment sum of squared, then error residuals. Okay, these are the statistical terms that you need to learn. So our model f value was 7555, which is very good. Then let's jump into the fit statistics. So we can see here our standard deviation, mean, coefficient of variation, r square, adjusted r square, these all the values are here. So here we can see a thing, the predicted r square is reasonable agreement with the adjusted r square. So our method is very good. Okay. Then adequate precision, we can see it is 267, which is very high because it need to be greater than 4. Yeah, our adequate precision is very high, so it is better. Then we can see the coefficient. You need to all you need to do is to just learn the statistical terms. Okay, then we can see the coded equation. Every equation will have a equation. Okay, will have a relationship between the dependent and independent variables. So this shows the dependent and independent variables relation. Then this is the actual equation. However, after performing the ANOVA, we can also see the model comparison statistics. So, okay, so you all just need to learn this. Then we'll press upon the diagnostics. Okay, so what this diagnostic means? This diagnostic means our responses which align with our mean value. Okay, we can see nearly all of the values are in the mean position. Then we can see the residual versus predicted. Okay, so this is our zero line, and some of our values are very much closer to that of uh, the mean line. Then we can see the residual versus line. So these are our runs in which this is the first run, this is the second run, this is the third run, and all over this is the ninth run. So this shows the variability of your result. Then residual versus factor, this also shows different runs which has already been conducted. Then we can see the box Cox plot. Actually these determine your different statistical term. Okay, then predicted versus actual, you can see uh, how much correlated your dependent and independent variables are. So this is the Cook distance. Okay, the result of your values has been shown here. Then this is the leverage. Then this is DFF ITS. You can see your values, you can just compare your values. Okay, then you can see DFB ETAS. This is actually the value, and this is the final report. So you can see all of your runs which has already been conducted. We are uh, dealing with the first run. Actually its statistical values are very much okay. Okay, then we will see the model graph. Here we can see the uh, percent of methanol, then this is the retention time. Okay, so this is the model graph. Just click upon 3D surface, you can see the relationship between the flow rate and percent of methanol. Okay, this is a 3D surface which show this is the x-axis, this is the y-axis, and this is the z-axis. Okay, so we can see 3D diagram, and the percent of methanol, whenever the percent of methanol increases, then our retention time decreases. Whenever our flow rate has increased, then our retention time has decreased. So this shows the correlation between uh, the dependent and independent variables. Then this is the predicted versus actual plot. We can see here our values was very much okay. Then this shows the contour plot. Okay, in the contour plot actually it shows different values of dependent and independent variables. So this shows the interaction, and you can also analyze your full all factors here. Okay, all factor means we have percent of methanol and another is flow rate, and dependent variable is retention of Hamilton. So this is the overall analysis, and I have shown one of the analysis, and you can do the same by just clicking start analysis. Okay, we will do now the retention time of vonoprazan. So start analysis, then you have to set the values, just click on them, then you will check the ANOVA, its value is better. Then you can see the standard deviation, f statistics, required precision is better because it is more than 4. Then you can go to diagnostics, you can see your value, the pattern of your value, you can see the predicted versus actual, you can see the residual versus run, residual versus predicted, residual versus factor. This shows actually your runs. Okay, this is the cook distance. Just learn them by clicking on Google. You can have the definition. These are the some statistical terms. You can see the leverage, you can see the DFF ITS. Okay, your runs that you have already carried on. Okay, then you can also generate your reports. Okay, so after that, go to the model graph. Okay, whenever you will go to the model graph, you can see that 3D surface. Okay, here we can see whenever your percent of methanol has been increased, your retention time of vonoprazan has decreased. Whenever flow rate has increased, then your retention time of vonoprazan has decreased. Okay, you can also see the contour plot here, then predicted versus actual. Okay, you can also see different interactions here. Also you can see all of the factors and their relationship between dependent and independent variables. You can also see one factor at a time. Okay, by using this all of the method, you can perform the statistical analysis. Just click on that and do the statistics. Okay, I'm not showing this, I'm just clicking upon this, and you'll just learn this one by one. I'm just clicking this, I'm just undergoing the analysis. Okay, here you can see I have just undergone the analysis. Whatever you have analyzed has already been clicked, okay, by analyzed. So this means I haven't yet analyzed the retention, uh, the resolution. Just click on that stat analysis, then just click on your A and B. Okay, then click on ANOVA. Then you can see every value is somehow very good because it is more than 4. Okay, that means your response is better. Okay, then you have p value, f value that I have already discussed. Then click on diagnostics, model graph. You can learn a lot by checking this. Okay, you can also understand your 3D graph. Okay, predicted versus actual plot. Okay, so whenever you need to download this for publishing in article, just click on the right and just copy and paste on your word file or anywhere else. Now we have already analyzed this. Our next turn is to optimize, method optimization. So how we will perform this? So to conduct this, first of all, we need to click on numerical. Okay, in numerical you will have a lot of criteria. Okay, so what should be our criteria? Our percent of methanol should be in range, our flow rate should be in range. Okay, so our retention time should be minimized. Why minimized? Because increasing the retention time will utilize a lot of solvent, so we have minimized this. Then our retention time of bonoprazone should be minimized. Then our tailing factor, every time we want that our tailing factor should be minimized because we don't want tailing factor more than 1, so it should be minimized. Then tailing factor of bonoprazone should be minimized. Then theoretical plate, the more theoretical plate, the more would be separation, so we should maximize this. Okay, same theoretical plate of vonoprazone, we should maximize this. And finally the resolution, we should maximize the resolution because we want better resolution. Okay, so these are the criteria that we have already set. Whenever we have set any criteria, your method is very ready for upcoming optimization. Then you will click on solution. Whenever you will perform the solution, you will have a result, a lot of result. Among these result, this solution is better. Okay, so now your solution has already come. That means if you run a HPLC method using 20% methanol at a flow rate of 1 ml per minute, then you will have this sorts of result, and this is the optimization of your method. All you need to do is to just run the method and just compare with this. Okay, so this is the overall solution of your study. Just click on the graph to have your overall data. Just you can also have a lot of interactions of your dependent and independent variables here. You can also see your all factors here. I can see here which one is directly proportional or which one is inversely proportional. Yes, you can also see one factor at a time. Okay, so this is your overall solution. Okay, by using the design expert software we have already solved our optimized solution. Okay, then this is the thing that you can do. Then you can also perform point prediction by using this method. Okay, in HPLC you can also do this point prediction. Then you can also perform the confirmation. Okay, just learn about this and just put the value. Then you can also confirmation. You can also have your coefficient table. Okay, so this is the coefficient table. You learn this by p value or f statistics or chi-square test, g test. These are the overall thing. So this is the overall thing that we have learned. If you have any confusion, please inform me in the comment section. I think you have hopefully learned this in easier manner. Thank you.